Hi guys, so you've made it to the second unit. In this particular section, we'll be looking at basically just breaking down functions and adding, subtracting, multiplying, dividing them. How does that coordinate then with their domains of those newly created functions? And then we will wrap up the class or this particular session here with the difference quotient, which plays a huge role for those of you moving on to calculus. Go ahead and I'm going to tell you right now this video is going to be a little bit on the long side because there's the material in this particular set of notes. When I was looking through it, I just felt like I needed to explain pretty much all of it and give you a verbal explanation. However, with that said, it still doesn't stop you if you ever feel like, oh, I can, let me pause the video, let me try it first. By all means, I definitely say go for it, but I felt like I still should provide a verbal explanation. All right, so with that said, let's go ahead and dive in. Here at the top, we're just basically defining what it is that we're going to be looking at, and essentially we're going to be adding, subtracting, multiplying, and dividing these functions, and then from there analyzing their domain, and domain is the biggest piece that we'll be looking at. Okay, all right, so at the front here, this notation f plus g of x, that's just simply f of x plus g of x. So just take your functions and add them together. F minus g of x is simply f of x minus g of x. Take the functions and subtract them. When your letters are here side by side, that just means to take each function and multiply them times one another. The domain for the top three functions that you're seeing here, the domain of each of those would be the overlap. So the domain would be the overlap of f and g. So I'm always going to have you find the domain of f, the domain of g, and then if we're doing any of these top three types of functions, it'll just be where those domains overlap. The bottom function, when you go to divide, f over g of x, well, hopefully you recognize, well, that could be rewritten as f of x, the function f of x divided by the function g of x, where g of x can't equal 0. Of course, like we've talked about before, the denominator cannot equal 0 because then you would be undefined. The domain for this particular function, any kind of division there, the domain of the function is still equal to the overlap. So it's still the overlap of f and g, and where your denominator cannot equal 0. And denominator cannot equal 0. So you've got to keep that in mind as well. Okay. All right, so I'm going to scoot on down here to example 1. Example 1, you're given a function for f of x and a function for g of x, and they want us to find the following. I'm actually going to do A with you, and I do believe that you can get letter B here with the solution key on your own. So that'll be I think that's the only one I'm not going to do with you. All right, so here starting straight away, what I would first do is rewrite this g minus f of negative 5 to say that I'm finding, make this a little bit smaller. I want to find g of negative 5 minus f of negative 5, like that. So kind of just utilizing the notation that you see up at the top. So now this first function says go to your g function. Everywhere you see an x, plug in negative 5. So my g function already has a negative sitting out there. Then I'm going to replace the x with negative 5. And then it's plus 2. So there's me plugging in to my g function. Down my minus sign. So I always recommend anytime you're substituting in a value, always use parentheses. Minus, now go to your f function. Everywhere you see an x, plug in negative 5. So you have x squared, so I have negative 5 in parentheses squared, minus 3 in parentheses negative 5. Close it up. Now from here, I want to get these brackets completely simplified down to one number before I do the subtraction in the middle. So the bracket on the left, this negative outside, two negatives side by side become positive. It's also referred to as the opposite of negative 5, so that would be positive 5 plus 2. And we could go ahead and clean that up, and we know, okay, that's 7. All right, so we've got that bracket taken care of. Let's look at the second bracket. You take a negative and you square it. So negative 5 squared, what that means is negative 5 times negative 5. So if you agree, that gives me positive 25. Then back here, let your operation determine your sign. Negative 3 times negative 5 gives us a positive 15. Still bringing down my minus sign. Now add together 25 plus 15, that gives me 40. And now from here, 7 minus 40 will give me negative 33. Final answer. Okay. All right. I encourage you to pause the video, try letter B, check yourself by the solution key, make sure you're tracking. All right, let's definitely now start. We'll step it up a notch here in example 2. Not just a tiny notch. So here in example 2, you're again given two functions, f of x and g of x. The first one here, they want us to find g times f of x and state its domain. Okay, so let's go ahead and establish from the beginning the domain of f of x and g of x. So our domain of f of x, let's think about that. So remember when we talked about in the last unit that your domain is only restricted if you have square roots or even roots. Let's give you more broad than that. If you have an even root of a radical, or if you have a denominator. Those are the big times whenever your domain is restricted. And hopefully you also recognize that this is a linear function with a slope and y-intercept, and so those are straight lines. And that means then that my domain, negative infinity to positive infinity. And then let's also look at my g function. So the domain of g of x, also a straight line, right? Y-intercept at -2, and then I've got a slope of up 4 over 1. So it's also just a straight line. So my domain there is going to be negative infinity to positive infinity. All right, so now let's actually come over here and find what it asks. It asks us to find g times f of x. So I'm going to take my g function. It basically means g of x times f of x. So take your g function, which is 4x minus 2, and we're going to multiply it times the f of x, negative x plus 1. I would just use the FOIL method here, right? Your FOIL method, multiply your first. So 4x times negative x. Remember, that's a -1 in front of that x. So 4 times -1, -4, x times x, x squared. That's your first. Outside, 4 times 1, 4x times 1. So that would give me plus 4x. Inside, -2 times -1, positive 2x. And then last, -2 times positive 1 will give me a -2. One last step, combine like terms. So -4x squared plus 6x minus 2. That is g times f of x. That would be our final answer there, -4x squared plus 6x minus 2. Now, if you think about it, we could graph this in our calculator and see what its domain is, but as I mentioned to you at the top, the domain of this function should be where these two overlap. Well, they're going to overlap everywhere, right? Negative infinity to positive infinity for both of them, so they're going to overlap everywhere. So that allows us to come to the conclusion that the domain of g times f of x is also negative infinity to positive infinity. Furthermore, from there, if you were to graph this function in y equals in your calculator and look at it, you would see that it's a parabola pointing downward, so that means it's going down and to the left forever, down and to the right forever, so its domain has to be negative infinity to positive infinity. So these, I'm going to box in, these were the two pieces that we were looking at there. We needed to find what the g times f of x was, and then what was its domain. Okay. All right, let's move on down to example 3. We'll stepping it up a notch here. Here I'm giving you a function h of x and k of x. I want you to find k over h of x. So remember, that just means, okay, I'm finding k of x over h of x. And what's probably, let's kind of continue with the same method that we were doing. Let's find the domain of h and k first. So the domain of h of x, again, what does that look like if you were to graph it? Hopefully you agree, a straight line, so its domain, negative infinity to positive infinity. Wouldn't have any restrictions. The domain of k of x has got a radical, an even radical, a square root, so we know that even radicals have to stay positive. So what needs to happen here is we need to set x plus 5 greater than or equal to 0 and solve for x. So when we do that, we'll just subtract 5 from both sides. So x is greater than or equal to negative 5. So then we can say, okay, well, my domain here then is going to go from negative 5 to infinity, like so. All right, and so now, sort of keeping that in mind, because remember now that the domain of what we're trying to find over here is going to be the overlap of this plus wherever we've got a denominator, because that denominator can't equal 0. So we'll just sort of kind of giving you a little bit of foreshadowing there. So now k of x, plug in that. So k of x is the square root of x plus 5. H of x is x plus 2. That's the function, okay? So I can't do any more reducing on that at all. So I have at this point found k of x over h of x, okay? We've found that part. Now let's talk about the domain. Think about the domain of this function. The domain of h over k, k over h, sorry. We were finding k over h. The domain of k over h means that h here cannot equal 0, right? My denominator here cannot equal 0, because if the denominator equals 0, my function's undefined. So I need to figure out then where the denominator would equal 0. So I say x plus 2 cannot equal 0. That's a quick solve. Just subtract 2 from both sides. So x cannot equal negative 2. So then what that allows me to see is that, okay, well, my new restriction here so far is that it's going to go from negative infinity to negative 2, and then from negative 2 to positive infinity. The overall domain, so now the overall domain of k of x over h of x is where all of this overlaps. So if we think about this on a number line, then let me draw my number line. So here's my number line. H of x says I can go from negative infinity to positive infinity. So h of x says I got the full number line at my disposal. K of x says that I have to have x values greater than or equal to negative 5. So let me put a 0 here and use a different color. So here's my negative 5. K of x says I need to be greater than or equal to that negative 5. So I'm going to put a bracket here, and I am shading to the right. Okay, so far you can see, well, I'm overlapping from negative 5 to positive infinity. But now throw in this last piece, and it says that I have a new restriction over here at negative 2. And it says that I go from, at the negative 2, I've got a parenthesis going both ways, and I am this way, and I am that way. So essentially now, my domain of k of x over h of x is where the blue line, the green line, and the red line are all on top of one another, okay? So that means I cannot include anything less than negative 5. That's not going to work. It's got to be over here on the right-hand side of negative 5. And you can see that from negative 5 to negative 2, there's a portion there of the graph. So from negative 5 to negative 2, the negative 5 gets a bracket, negative 2 will be a parenthesis, and then I pick back up and I can go from negative 2 to infinity, because that's where all three of those colors are on top of one another. That represents all three of these segments of the function, okay? And that would be your final answer for the domain, okay? So you would want both of those pieces, this one and this one, okay? All right, let's flip it on over. Top of the next page, giving you two functions, f of x and g of x. In letter A, I ask you to find the domain of f of x, and this might be a good opportunity. Pause the video and decide for yourself, what's the domain of f of x and g of x? And I'm just going to go ahead and jump right in. The domain of f of x, straight line, so that should be negative infinity to positive infinity. G of x, a parabola, this time facing upward, so that means it's going up and to the left and up and to the right forever. So it's also negative infinity to positive infinity. Letter C says, okay, well, what's the domain then if you were to add, subtract, multiply um, those, or even if you wanted to do, so I have here F times G, but I mean, I'm also not restricting. I could do G times F. I could even do F times F. What would be the domain of those? And if you remember back on the front page, any combination of addition, subtraction, or multiplication will always be the overlap of these two functions. And so they're going to overlap everywhere, negative infinity to positive infinity. We got to look a little bit further, though, into letter D and E, where we want the domain of F over G and G over F. Okay, so think about the function F over G. The function F over G, let's first write that. The function F over G would be equal to F of X over G of X. So I need to figure out where the bottom here would be equal to 0. So I need to set x squared plus 5x plus 6 equal to 0. And essentially, I don't want it to equal 0 because I need it to not equal 0. The way that you solve a quadratic like this is that you actually need to factor. If you need help with factoring, I have created a factoring document for you in Blackboard, so definitely check that out, okay? So now, sorry, let me get back. Okay. All right. Factoring. This one's not too bad, though, if you're not up to speed with factoring. The only way to multiply to give you x squared, x and x times x is the only way to multiply to give you x squared. Now, what goes in the last spots are ways to multiply to give you 6. So there's 2 ways to multiply to give you 6. 3 times 2 and 1 times 6. In this particular case, 3 and 2 is what's going to work for us. And the way you check yourself is that you multiply on the outside, 2 times x, you're getting 2x. On the inside, 3 times x, you're getting 3x. Your goal is to get this middle term, so my goal is to get 5x. The only way I'm going to be able to get that is to make both of those positive. And then the last check for yourself is to make sure that your last terms, 3 times 2, equal the last term here, which is 6. Okay, so we've got it factored. Now we set both of those factors, they both have x's with them, so we set both of those factors not equal to 0. So x plus 3 can't equal 0, x plus 2 can't equal 0. So we just do a quick solve. We find, okay, x can't equal negative 3, and over here, x cannot equal negative 2. So now, at this point, if we think about graphing on our number line, then if we're doing f over g, then the domain of f of x and g of x is the entire number line. F of x and g of x are both negative infinity, positive infinity. So that's the entire number line. F over g starts, though, to pick up a little bit of a restriction. It says you can't equal negative 2 and you can't equal negative 3. And so then what that looks like is that, it's a different color, that we have here at negative 3, and we can go everywhere else. And then at different color, what do I need? Maybe it goes there. At negative 2. And I go everywhere else. And I'm looking, I want to write then where I have my blue, green, and black lines overlapping. And so hopefully you would then agree that they're overlapping from negative infinity to negative 3, from negative 3 to negative 2. Oh, I forgot my little union there. And then from negative 2 to positive infinity. Okay. All right. I encourage you to do letter E. Maybe pause the video and try letter E. Okay. I think you can follow that one with the solution key. Let's look at letter F. In letter F, it wants us to find f minus g of x. So remember, f minus g of x just means f of x minus g of x. let's use brackets. So in place of f of x, let's put in the f of x function. So that's x plus 3. In place of g of x, I'm going to use brackets and put in the g of x function, x squared plus 5x plus 6. It's super important, especially with the subtraction sign, that you use the bracket, because remember, that minus sign sitting out here is like a -1 that now has to be distributed to every term in that bracket, okay? So what happens now is that I bring down the x plus 3. I can't do any combining. Take that -1 and distribute it. So you have minus x squared minus 5x minus 6. And then our last step then would be to combine like terms. Usually you write this in descending order. So you have negative x squared. This is a positive 1x and a negative 5x, so minus 4x. Positive 3 minus 6 will give us negative 3. So final answer. That would be your final answer, okay? Let's look at letter G. In letter G, it says g over f of x, so that means g of x divided by f of x. So we put in our g of x function. That's x squared plus 5x plus 6 over x plus 3. Always be on the lookout for reducing if you can. In this problem, you actually can reduce. I already showed you previously that we know how we can factor the top. So factor that top, and was x plus 2, x plus 3. Then on the bottom, you have an x plus 3. It's legal then to cancel out as long as it's identical. You can cancel out. It wouldn't be legal if this was down here was maybe x plus 5. It wouldn't be legal for me to, oh, let me just cancel out the x's. Okay, that wouldn't be legal. But you can cancel out a full pair here. Okay, so I can cancel out x plus 3 with x plus 3, and so that equals x plus 2. So our final answer here then of g over f of x would be just x plus 2. Okay, you would actually you would end up having a hole at -3 on your graph. Okay, so that would be something that you would talk a little bit more about. We'll talk a little bit more about in this class, and even more so when you get to calculus. Okay, all right, let's look on down here at letter H. In letter H, we are multiplying g times f of x. So we're just taking these two functions and multiplying. You can do this any way that you like. I personally like to set it up like long multiplication. So I always put the term or the function that has the most terms up top. So that would be my g function, which is, I think, is it the g function? Yes. So it's x squared plus 5x plus 6, and then I'm going to multiply it times x plus 3. You don't have to do it my way. I'm just showing you a way. When you write it like this now, I think it helps keep everything lined up. Okay, you like your like terms. So just do this like you would do normal long multiplication. So 3 times 6 is 18. 3 times 5x, 15x. 3 times x squared, 3x squared. Now we're going to take and multiply x times everything up top. So x times 6, 6x. If you think about when you normally do long multiplication, you always move in one. Just always put it underneath its like term. X times 5x, 5x squared. And then x times x squared will give you x cubed. And now just add down. Here's everything's all lined up. So you've got x cubed plus 8x squared plus, how's that, 21x plus 18. Final answer. Okay. Again, you don't have to do it my way. Whatever way works for you, as long as you can do the multiplication there, it does not matter to me. In letter I, you're just multiplying f of x times f of x. So I'm going to let you check the solution key for that one. Okay, we'll pause the video so you can kind of do it in real time. Okay, all right, let's flip it on over. This page, there's a lot going on. Okay, so there's a lot to talk about in this one. All right, so in example 5, here are your two functions, f of x and g of x. They want us to find f over g of x and state its domain. Okay, I think we're actually gonna we'll do it in that order. We won't start with finding it. We'll go ahead and find f over g of x, and then we'll work on the domain. Okay, all right. So f over g of x. Remember that just means f of x divided by g of x. So in place of f of x, that's 1 over x plus 2. In place of g of x over x minus 1. Now, I don't know if you remember how to clean up a fraction within a fraction. The rule is that you copy the top, change it to multiplication, and flip the bottom. So it will look like this. Copy the top, 1 over x plus 2, times, flip the bottom, x minus 1 over x. And now, when you multiply fractions, you just multiply straight across. So 1 times anything up top is just itself. So you have x minus 1 up top. Then on the bottom, you can distribute this, or you can just leave it like this, x parentheses x plus 2. Or if you distribute, it would be x minus 1 over x squared plus 2x. Either one of those would be fine. Okay. All right, so now let's go back and let's focus now on the domain. All right, so the domain of f of x, because remember the domain of this function is going to be where the domain of f, g, and this all overlap. So let's start with the domain of f. The domain of f of x. So for our domain of f of x, it's a rational expression here. We have a denominator, so that means that my denominator there cannot equal 0. So I solve for x there. That's a quick solve. Subtract 2 from both sides. So x cannot equal -2. So we're picking up a domain here then from -infinity to -2, -2 to positive infinity. All right, let's look at the domain of g. Domain g of x. So I have my g of x function, x over x minus 1, all over f function. Oh, wait a minute. No, sorry. God, goodness gracious. Sorry. Domain of g of x. I'm just focused on the domain, sorry. Just focused on the domain. I just need to set the denominator. X minus 1 cannot equal 0. So now from here, add 1 to both sides. So now we know, okay, x cannot equal positive 1. So now we're picking up a new domain restriction from -infinity to 1 and 1 to infinity. Okay. And lastly, to look at the domain of f over g, that means then that g cannot equal 0. So your g function, the g function, that means then that x over x minus 1 cannot equal 0. Okay, we haven't seen anything like this before. What I'm going to do is I'm just going to put a 1 underneath the 0, right? Because 0 divided by 1 is still 0, so it's still the same thing. Now, in order to solve something like this, all you do is cross multiply. So 1 times x is x, and then over here, x minus 1 times 0 is still 0, and it's still saying, okay, well, x cannot equal 0. Usually there's sometimes a little bit more to solve, but in this point, we've already got it solved for x. So x, we're now picking up a new domain restriction and saying it's going from -infinity to 0, union 0 to infinity. So now let's draw a number line over here, and let's put it all out so we can pick out our final domain for f of x over g of x. So I'm going to try to color code it here. So we said that our f of x function was restricted over here at -2. So here's, I'm going to kind of exaggerate here. So here's my -2, and I've got parentheses, and I go to the left forever, and I go to the right forever. My g of x function says it's restricted from -infinity to 1 and 1 to infinity. So we'll come over here, we'll put a positive 1, also parentheses on everything, and we are shading to the left forever and to the right forever. And then let's look at our f over g. We picked up this new restriction at 0, that we were now going to the left and to the right. And so, like we've said before, now your domain is where all three of those colors, the black, purple, and green, are all on top of one another. So hopefully you would agree, it's a domain that's just been broken up into little pieces. That my overall domain here is going to come in from negative infinity to negative 2. It's got to stop there, right? Because you can't equal negative 2. Then it's going to go from negative 2 to 0, my little union there, 0 to 1, and then 1 to infinity. So it just breaks it up into 4 separate segments, okay? But that's what you would need to list as your ultimate domain for that function, f of x over g of x, okay? If you're feeling good about that one, you might want to pause the video then and try example 6 from top to bottom. I'm gonna though go ahead and still work this one because I know that there was a lot going on in that problem, and I think you would benefit from possibly hearing another one going from top to bottom. All right, so let's look at example 6 here. It is, again, here's an f of x and a g of x, and it wants us to find f over g of x. So we'll go ahead and get started here. I want f over g of x just means f of x divided by g of x. Plug in your f of x up top, so x over x plus 3, g of x on the bottom, 5 over x plus 2. Just like we said, in order to clean this up, copy the top, change it to multiplication, and flip. From here, we can leave it like this, x parentheses x plus 2, over on the bottom, 5 parentheses x plus 3. Or go ahead and multiply that out and say, okay, well, this is x squared plus 2x over 5x plus 15. Either one would be legal. I'm not sure if MyLab Math has a more preferred method, though. All right, so now let's start looking at our domains. So let's look at the domain of f. For your domain of f of x, looking at that f of x function, notice you got a denominator there, so that denominator cannot equal 0. Otherwise, it'd be undefined. Quick solve here, subtract 3 from both sides. All right, so now we know x cannot equal negative 3. We're picking up a domain restriction from negative infinity to negative 3, and then from negative 3 to infinity. All right, let's look at our g function, domain of g. Also another rational function. We know that it's got a denominator there. That denominator cannot equal 0. So we set that denominator not equal to 0 and solve for x. So subtract 2 from both sides. X cannot equal negative 2. So now we pick up a new restriction from negative infinity to negative 2. And then negative 2 to infinity. And then lastly, for your domain of, let me use a different color. For your domain of f over g, remember that means that g cannot equal 0. So in our case here, my g function, what's my g function? Is that the 5? Yeah. So that means then that 5 over x plus 2 cannot equal 0. Put a 1 underneath that 0. Cross multiply. So 1 times 5 is 5. And then cross multiplying this way, x plus 2 times 0 is 0. And so what you see here then is, well, 5 cannot equal 0. What that means then is I don't have anything to solve here, and so we have no new values to exclude from the domain. Okay. We did not pick up anything new there because I didn't have an x left over down here to solve for. Okay. So now if we come up here to our number line and figure out, okay, what's my ultimate domain then? I'll put my 0 here in the center, and at -3, make this -3. I can't equal -3, but I can go to the left and right on either side of it. Likewise for -2, I can't equal it, but I can go to the left and to the right on either side of it. So my ultimate domain then of f of x over g of x would be where the green and the purple in this case are on top of one another, so that would be from -infinity to -3. Unite that from -3 to -2, and then unite that with -2 to positive infinity. So 3 separate pieces there for your domain. Okay. These take a lot of getting used to. They take practice. Okay, you can't just do 2 of these and be good to go. So definitely be sure you put some time and effort into practicing some more with these. Okay. All right, let's flip it on over. Last piece that we'll look at is the difference quotient. And like I said before, those of you going on to calculus, this is going to play a major role. It is the hot topic in the first unit when you start talking about limits. Okay, but we won't dive into limits in this particular class. Essentially, kind of bridging the gap though. Of course, you already know how to find the slope or average rate of change of a straight line, right? And we just use our typical slope formula, y2 minus y1 over x2 minus x1. But how would you find the slope or average rate of change of a nonlinear function? Like you see this little parabola here. How would you do that? And we use what is referred to as the difference quotient. And the difference quotient comes from actually the slope formula. And I'm not sure how well the graphic comes in over on the video or not, but I'm going to write that ordered pairs. I'm going to write those ordered pairs for you again. That this ordered pair is x plus h, comma, f of x plus h. And this ordered pair down here is x, comma, f of x. Think about it as x, and remember f of x is y. Okay, and this h is supposed to be a really small distance away from the other point down here, but in order for you to be able to see it and visualize it, most textbooks will put it further away just so you can. But this h is intended to be a really teeny distance between from x. Okay, so this point over here is just h units away from x, a really small unit. In most cases 0.001. It's kind of like we're magnifying this parabola. Okay, and then the y value would be f of that x plus h. All right, so let's think of this then as the point down below. This will be your first order pair, so this is your first order pair, so I'm going to call this x1 y1. And up here, this is going to be your second order pair, so we're going to call this x2, y2. And we're going to use the slope formula to derive this for you. You won't have to y2 minus y1 over x2 minus x1. You won't have to memorize the difference quotient now. You most likely will in calculus, but you won't have to now. It would be something that I would give you. But nevertheless, I want to derive it for you. So just so that, like I said, those of you going on to calculus, you know where it came from. So y2 in my function here is f of x plus h minus y1 f of x, all divided by, on the bottom, x2, so x2 is x plus h, minus x1, so minus x. I can't do any cleaning up top, so I'm just going to rewrite that, f of x plus h minus f of x. But on the bottom, these x's, hopefully you agree, cancel out. You've got a positive x and a negative x. They cancel out and just leave you with an h on the bottom. This is the difference quotient. In calculus, you will be taking the limit as this h down here goes to 0. Okay, so but again, that's not where we are now. But you are going to be calculating this for me now. Okay, the steps for finding the difference quotient, getting this under your belt for those of you going on to calculus, will help you tremendously. Okay, all right. So with that said, find f of x plus h. So that's always the first thing that you find. And once you find f of x plus h, all of the other pieces are already found for you, and you plug them into this formula, okay? So again, I derived it here for you. When it comes time for the test, this would be a formula that I would supply for you, okay? All right, so we'll come on down here then and look at the first example. Find the difference question. F of x equals 3x squared minus 2x plus 3. Ultimate goal is we're finding f of, come over here, let's give myself a little bit more room. I want to find f of x plus h minus f of x all divided by h. Okay, so as the directions say, first thing you find is f of x plus h. So that means everywhere we see an x, we're plugging in x plus h. So x plus h squared minus 2 times x plus h plus 3. And I know this, for some folks, this always trips them up. But if I had asked you to find f of 4, you wouldn't have had any trouble doing it, because you would have said everywhere you see an x, you would have plugged in 4, right? So that's the same thing that I'm asking you to do here, except replacing your x with x plus h. Everywhere you see an x, plug in x plus h. Okay, I just pulled that out of my head here because I just wanted to make sure you were tracking with me. So now from here, this is the point where we do the most work. Okay, so I've got a power here. I got to take care of it. That squared means to write it twice. So x plus h times x plus h. We can go ahead and take this -2 and distribute it. So -2 times x minus 2x. -2 times h minus 2h plus 3. Now, what I would recommend that you do from at the next step, I would recommend that you FOIL these two parentheses together before you do the 3, okay? If you're going to do the 3 only goes to one parenthesis. It does not go to both. I'm just going to bring the 3 down, though, and go ahead and FOIL. So first, x times x squared first, outside, plus xh, inside, plus xh, last, h times h squared. Bring everything else down, minus 2x minus 2h plus 3. Even before I distribute that 3, I've got like terms in that parenthesis. Let's go ahead and combine them. X squared plus 2xh plus h squared. Now take that 3 and distribute. 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 3. All right, so that, now trust me, at that point you have done the hard part. Now you're actually ready to go over here to your difference quotient formula and plug in all the pieces. So it says you take your f of x plus h, that's what we just found. Here is f of x plus h. So you take your f of x plus h, I'm going to use a bracket just so you kind of have it all kind of separated here. So it's 3x squared plus 6xh. Just copying what I just wrote. Now you subtract f of x. You don't have to do any work. F of x was given to you. So you subtract 3x squared minus 2x plus 3. And then all of this is divided by h. We're going to take now this negative in front of that back bracket, take that -1 and distribute it through. So I'm just going to bring down the first bracket. So I have 3x squared. Just bringing it all down. Minus 3x squared, negative times a negative, positive 2x, negative times positive, -3, all over h. Here's what you should find now at this point. Every term that does not have an h in it should cancel out. So let's make sure that it does. Every term that does not have an h in it should cancel out. So this positive 3x squared does not have an h in it. Oh, look back here. I've got a negative 3x squared. So sure enough, it's canceling out. Next couple of terms, they've got h's in them. Here's your next term, negative 2x. Look there. Negative 2x, positive 2x. It's gone. Next term has an h in it. Next term, positive 3, negative 3. It's gone. Everything that I have left all has an h in it. So let me write that out. 6xh plus 3h squared minus 2h all divided by h. Okay. I'm going to burn an extra step here. Some folks might be able to just go straight from here to the final answer. I'm going to burn an extra step. Hopefully you notice that all three terms up top all have an h in common. Factor that h out. So when I factor that h out, that leaves me then with 6x plus 3h minus 2. And then on the bottom, divided by h. What happens to the h up top and the h on the bottom? Hopefully you agree. They cancel out, right? So they're now gone. And that leaves you now with a final answer of 6x plus 3h minus 2. And then, like I said, in calculus, you would take that one step further and now take the limit of that as your h here goes to 0. Most likely in calculus, instead of h, they'll use a delta x. But it's the same thing, okay? All right. If you want, pause the video, try example 8 on your own. Maybe try to get as far as you can, and you might even like watch part of the video or try some, get stuck, watch part of the video and say, oh yeah, remember, and stop the video again. Just trying to help, give you some cues to kind of help you through learning this on your own. Okay, so now looking here at number 8, if I'm going to also want to use my difference quotient here to find the difference quotient. So first thing I need to find, f of x plus h. So that means everywhere I see an x, I'm plugging in x plus h. So 4 parentheses x plus h squared plus 2 parentheses x plus h minus 1. Okay. Got to start cleaning up. So this is 4. Remember that in parentheses squared means to write it twice. So x plus h times x plus h. I can take that 2 and distribute. So plus 2x plus 2h minus 1. Bring down the 4. I would FOIL now here. So x times x squared. Once you start doing enough of these, you're going to find that x plus h times x plus h is always going to be this, x squared plus xh plus xh plus h squared. It doesn't change. I'm going to burn an extra step here. Let's go ahead and combine like terms. So x squared plus 2xh plus h squared plus 2x plus 2h minus 1. Let's distribute that 4. Plus 4h squared. Okay. Now from here, I'm ready to go to my difference quotient. Difference quotient was, I'm gonna come on down here. It is f of x plus h minus f of x all divided by h. So filling in what we know, we just found f of x plus h. That's this piece. So all of that is going to come in and take care of this. So I'm going to start my bracket. 4x squared plus 8xh. Just keep copying. That's f of x plus h. Now you subtract f of x. Remember, f of x is given to you right at the very beginning. That's f of x. So subtract your 4x squared plus 2x minus 1. All of that's divided by an h. Okay. Remember, you've got a negative 1 that's got to be distributed to all 3 of these terms back here. So let's bring down that first bracket. Minus 4x squared minus 2x plus 1, all divided by h. And then, like I said before, any term that does not have an h in it should be canceling out. So sure enough, I've got a positive 4x squared, I've got a negative 4x squared. So those are gone. I've got a positive 2x, I got a negative 2x. Those are gone. I've got a -1 and a +1. Those are gone. So now, write what I have left over. 8xh plus 4h squared plus 2h. That's all that I have left over, all divided by h. Just like you saw in the last problem, every term up top has an h in common. Factor it out. Write what you have left over. It's now legal to cancel out those h's to give you a final answer of 8x plus 4h plus 2. Okay, all right. That finishes this section up, and let me know if you need anything. Thanks a lot.